Um, Good day, everybody. Um, as far as teaching and learning is concerned, we tend to learn more when we use audio visuals, and that is why today, by the special grace of God, we are going to present a short video telling you about how to give names to organic compounds. You know that when you give birth to children, one of the most important responsibilities is giving names to the children. As far as human beings are concerned, what we are actually after is giving beautiful names to our children. But as far as organic compounds are concerned, there are rules and system of giving names to organic compounds. And that is why organic compounds in Nigeria has the same name in America, irrespective of the geographic location. Now, not to waste any of our time, compounds, organic chemistry. There are some rules that we must follow whenever we are giving names to organic compounds. Number one is select the longest continuous carbon chain. That's just language. What this simply means is that look at the compound, look at the carbon atoms, select the longest one, you count it. For instance, this is a compound. Let's count the longest continuous. There is continuous. This is very important. Continuous chain. 1, 2, 3. This is a possibility. We can also have 1, 2, 3. This is still in continuous process. You cannot say 1, 2, 3, 4. Do you understand? Because the carbon atoms should bond with each other. So you select the longest continuous chain. 1, 2, 3, 1, 2, 3. There is no other carbon attached to this carbon directly. But this one is not in the continuous process. Alright. Number 2. As far as the rules are concerned, immediately you've selected the longest continuous chain, carbon chain. The number 2 is number the longest carbon chain, starting from the end that gives lowest possible number to the functional group. Here we have a keyword, functional group. Already, I told you about functional group, but for the benefits of this presentation, functional group, as human beings, we have some traits in us that is common to all of our family members. Some family members, they are tall, some family members, they are short, some family members, they are light in complexion, some family members, they are intelligent, some family members, things like that. Even in our bloodstream. For instance, the present governor of Kaduna State, if I'm not mistaken, said that in his family they have not gotten old to more than a certain age. That is the first person to break that genes. So, which means there are some characteristics, there are some traits that are familiar to each and every family. Yet, in chemistry, in organic compounds, there are some traits, there are some characteristics that are common to members of homologous series. Yeah, and that is what we call functional group. If you are to define that, to say it is an atom, a group of atoms or a radical which is common to a homologous series and determines the chemical properties of the series. Good. Now, which means we must give the functional group the lowest number possible. For alkanes, for instance, the functional group is a single bond. For alkenes, the functional group is a double bond. So, if you look at this is an alkane. We give the functional group the lowest number possible. Alright? Then if you look at this is an alkane too. We can number the carbon atom in continuous chain. 1, 2, 3, 4, 5. There is no other carbon atom attached to this. Or 1, 2, 3. This is shorter. Or 1, 2, 3, 4, 5. Good. Look at this as well. But before we get here, the second point is to give the functional group the lowest number possible. The third one is to indicate the other substituents. What do we mean by substituents? I usually use attaché, a group of atoms, or even an atom that is attached to the parent chain. It is not part of the longest chain of carbon atoms. For instance, if you consider this first organic compound, number 1, number 2, number 3, this is a chain. 1, 2, 3. This is another chain, which means if I should decide to pick 1, 2, 3, which means I have a substituent on carbon number 2, which means I have an attaché, a substituent on carbon number 2. So you indicate it by prefixes preceded by numbers to show their position on the carbon chain. What do we mean by that? What is the name of this group attached on carbon number 2? And that is why a class that is preceding this class is definition of terms in organic chemistry. I've just defined functional group. By that way, I've typically or stylishly defined homologous series. Yes, one of those terms that we have defined before this class is alkyl group. Alkyl group. So this is an alkyl group. Why is it an alkyl group? Because it is derived from an alkane just by the removal of an hydrogen. For instance, methane is CH4. This is methane. So by the simple removal of an hydrogen, this becomes CH3. It becomes what? CH3. And the name will now change from methane to what? To methyl. From methane to methyl. So if you are naming this compound now, the substituents will come first. What is the substituent? Methyl. You must also indicate the number and preceded by numbers to show their position. The position of the substituent on the main straight or long chain, on the main continuous parent hydrocarbon. You indicate the what? You indicate the position. 1, 2 is on position number 2. So you say 2. You write that 2 as a number. Then you use hyphen to separate number from letters. This is the system. 2, what's the substituent? Or we call it attaché. What's the substituent? Methyl. Methyl. Do you understand? Is there any other substituent in the compound? No. All other atoms that you have are hydrogen atoms. So 1, 2, 3, 2 methyl propane. Already, a class that preceded this class again is giving names to the first 10 members of alkane. When it is 1 carbon atom, is methane. 2 carbon atoms, ethane, propane, butane. Now 3 carbon atoms, we have propane. So in this case, we have 1, 2, 3. So the name of this compound is 2-methyl propane. If you want to, if you are not clear about this, you can easily pause the video and go back and watch it again. Alright? So this is the name of this compound. Now let's follow the same knowledge, the same understanding. The first thing, like I said earlier on, is to count the longest chain, continuous carbon chain. Count the longest continuous carbon chain. So this is 1, 2, 3, 4, 5. There is no other carbon attached to this. Are we there? There is no other carbon atom attached to this. Or we can also make this 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. Anyway, the counting, the selection that we are going to stick with is the one that gives the longest carbon atom, the longest possible chain. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We can either pick this or pick this. Clockwise, you can either count clockwise or count anti-clockwise. But do you know what? Let me give you this for free of charge. Whenever you are naming organic compounds, there may be more than 3 possible ways of giving a name to a compound, Iupac name. But just one of the 3 possible ways will be correct. And that is why in past questions, what we usually do is to include the possible names. And in the options, we have the possible names and the correct name. So one correct name and 3 other wrong names. So how do we name this? The first thing is to count the longest carbon chain. 1, 2, 3, 4, 5. That's number 1. Number 2 is number the longest chain, starting from the lowest end, the end that gives lowest possible number, to the what? To the functional group. This is an alkane. There is no typical different functional group like OH, like CHO, like COR, like Cl. The third thing is to give the substituents the lowest number possible. Indicate the substituent and give it the lowest number possible. In this case now, if I should say 1, 2, 3, 4, 5, the substituent, this is a substituent. It will be on carbon number 2, that will be 2-methyl. If I should count clockwise, 1, 2, 3, 4, this group CH3 will be on carbon number 4, so that will be 4-methyl. Both of these cannot be correct. I'm not done with the name. You know, I have to write the parent name as well, the main chain. 1, 2, 3, 4, 5. When hydrocarbon, particularly alkene, when they have 5 carbon atoms, they are called what? Pentane. Pentane. So this is 2-methyl pentane or 4-methyl pentane. These two names cannot be correct. Why? One is giving me, is taking the substituent, giving the substituent the lowest number possible, and the other one is giving the substituent a higher number. So which one is the correct one? This is correct and this is wrong. Alright, if you still don't understand properly, you can pause the video, go back again and listen once again. Alright, now let's go to compound 3. This compound 3, we have the first thing is to number the longest chain of the carbon. I can begin to have 1, 2, 3, 4, 5, 6, 7, 8. I can also have 1, 2, 3, 4, 5, 6, 7, 8. Do you understand? I can equally have 1, 2, 3, 4, 5, or 1, or what? Or I have 1, 2, 3, 4, 5. Continuous. The chain should be continuous. So the responsibility is to pick the longest chain. You can see that I have 1 to 8. There is a possibility of having 8 carbon atoms. There is another possibility of having 5 carbon atoms. So I stick with the one that gives me the longer carbon atoms, and that is 8. So all these ones, they are wrong. So I stick with the one giving me 8 carbon atoms as the parent hydrocarbon. So 8. It means the name must end with what? With octane. Now the next thing is to look at the substituent. If I'm counting this way, or I'm counting this, before I proceed, I can still say this is 1, 2, 3, 4, 5, 6, 7, 8. It is still 8. It is still 8. Alright? So what I'm interested in is doing what? Is knowing the substituent. If I should consider 1, 2, 3, 4, 5, I have this as substituent. I also have this as substituent, attached to the main chain. I also have this as substituent. But I have 2 possible ways of configuration for these hydrocarbons. I can either count anti-clockwise or count clockwise. I'm going to select the one that will give the substituent the lowest number possible. If I should count like this, it means this will be 1, 2, 3, 4, 5. It means I'm going to have methyl group on carbon number 5. That will be 5-methyl. Are we there? I'm also going to have on carbon number 6. I'm going to have ethyl group, 6 ethyl. Why is this ethyl? This is C2. If you count it all together, that is C2H5. And you know that C2H6 is what? Is ethane. So this C2H5 will be what? Ethyl. Will be ethyl. So this is because we just remove one hydrogen from ethane to get ethyl. So this is 6 ethyl. On this same carbon number 6, I have another 6 ethyl. That is possibility number 1. Possibility number 2 is to count from the right hand side. 1, 2, 3. Which means on carbon number 3, that is 3 ethyl. Ethyl, this is 3 ethyl. On top as well, you have 3 ethyl. Then the next substituent that we have 1, 2, 3, 4 is on carbon number what? Carbon number 4. So that is 4 ethyl. Between 3, 3, 4 and 5, 6, 6, which one is the shorter number? You believe that the shorter number is what? Is this one? 3, 3, 4. That's the shorter number. That's the shorter number. All right. So we are going to stick with this and not with this. All right. So, however, if you are having more than 2 substituents, there is a point here. If the same substituent occurs more than once as side chain, show how many are present by using prefix di. Di means 2. Tri means 3. Tetra means 4. Penta means 5. And indicate by various numbers of their positions. So which means we have 2 different ethyl. So it means I'm going to say the name of this compound is 3, we have another one, another ethyl on carbon number 4. 4 ethyl, 4 di-ethyl, because we have 2 ethyl. One on position number 3, the other one on position number 4. 3, 3. No. One on position, both of them are on position number. This is methyl, not ethyl. Both of them are on position number 3. So that will be 3, 3 di-ethyl. Then on position number 4, you have 4 methyl. You've named the substituent, then the parent name, octane. So this is 3, 3 di-ethyl, 4 methyl, octane. 3, 3 di what? Di-ethyl, 4 methyl, octane. I'll just give you this number 4, and you make number 5 as what? As exercise. You take number 5 as exercise. Like I said earlier on, what do we do? But before then, I think there is one more of the rules. If there are several different substituents, name them in I think we've done that. Alphabetical order. There are different substituents. In this case, we have ethyl and methyl. We have ethyl and methyl. If you go to your alphabet, you have E before N. So E must come before N. And that is why this cannot be called 4 methyl 3, 3 di-ethyl. You give cognizance to the alphabet, E before N. So that is why this is correct. Then this last one, number 4. Like I said earlier on, the first thing is to number the carbon atoms. 1, 2, 3. Possibility 1, 1, 2, 3. Possibility 2. Possibility what? Possibility 2. 1, 2, 3. Which one are we going to stick with? We are going to stick with the one that gives us the lowest number of the functional group. In this case, we take the functional group as OH, which means this compound is an alcohol. Is an alcohol. It belongs to alkanol homologous series. Now, which one will give it the lowest number possible? It means it is 1, 2, 3. So we cancel this. We won't take this any longer. All right. Next thing is to look for the substituents. We have two substituents, chlorine and bromine atoms. Now, when chlorine becomes a substituent, it is no longer called chlorine, it is called chloro. When bromine becomes a substituent, it is no longer called bromine, it is called bromo. When any halogen becomes a substituent, they are not called their name again. It is allo, bromine, bromo, chlorine, chloro, iodine, iodo. Now, how do we name this? Where does this first substituent fall into? It falls into 2-chloro. It falls into position number 2. This one falls in position number what? Number 3. That's 3-bromo. So we attach 3-bromo, 2-chloro, and the parent name 1, 2, 3 propane. We join the name together. The parent name is propane. The substituent, no, the parent name is propanol because it belongs to alcohol. The substituent 3-bromo and 2-chloro. And like the last rule says, you name them alphabetically. The substituent must be named alphabetically. So this will be, because we have B before C. So the name of that compound will be 3-bromo, 2-chloro, not 2-chloro, 3-bromo, because B comes before C in our alphabet. Then the parent name 1, 2, 3, propanol or propanol. This one is showing me the position of this OH, because it is possible for this OH to move from carbon number 1 to carbon number 2. So this is what? 3-bromo, 2-chloro, propan, 1-O. So ladies and gentlemen, I believe I've been able to teach you how to name organic compounds. By His grace, we'll continue to, we extend the class other time, and by just working on typical examples. Thank you for watching.